a quick question. Let's try this current electricity question. Let's read it. In the circuit given, the interresistance of the electric cell of EMF E0 and E1 can be neglected. There is no current flow through the cell of EMF E1. The ratio of E1 and E0 is right. Basically, it's a current electricity question. Let's try it now. So as usually, I am suggesting you try the question first, and then let's go through with the answer. Right. Say now in the question they are telling there is no current. See, no current flow through the cell E. So the current through this is 0. That means basically we know E1 cell will try to send certain current towards this direction, right? But if there is no current, that means there will be another force towards this direction, EMF, electromotive force in this direction and electromotive force in this direction, and both has to be equal, right? So the force towards this direction is E1, so then the force towards this direction should be E1. So that means the potential difference across these 2 points, I am highlighting these 2 points, let's say point A and point B. Point A and point B potential difference, remember that it's E1. So potential difference across point A and point B is E1, right? So then the current only flows through this E0, it goes up here like this and it will come back here, right? If the current flow is I, now you know the equation, V equals E minus IR. What's this equation? If there's an internal resistance for a cell, the external voltage will be E minus IR. But here they are telling it there's no interresistance, but let's assume this R also inside of this. Say it's something like that. Then the potential difference across AB, it has to be E0 minus, now you know, so this is not R anymore, it's R, E minus IR. Hope you understand it. And this V value, it has to be equal to E1, right? Right, let's write it again now. E1 equals E0 minus IR. We have an equation. Let's say now if we can find this I value we have to replace from E value. Say we can apply Kirchhoff law into this loop. So it's E0 divided by total resistance R. So it's 3R. That has to be equal to I. So let's apply that value over here. Right, E1 minus E0 I, E0 over 3R multiplied by R, right? So R and R cancel off, so E0 minus E0 over 3, right? So then E1 will be equal to 2 E0 over 3. Basically they are asking E1 over E0, so E0 should go this way. So we are getting E1 over E0 equals 2 over 3. Alright students, this is the answer then, third one. Right, I know what you are saying. Yes, there can be plenty of methods to do this question for sure, but this method is quite easier. It is actually same concept we are using in potentiometer. If there's no current through a cell, right, in the potentiometer cell, the measuring cell, and there will be opposite, in the opposite direction there will be another potential. So that's the theory we applied here. So go through with the method I did again. You will learn something here for sure. Right, cheers.
I hope you have tried all those questions now. You have learned something from it. And always remember that practice makes it permanent. So what we have to do is we have to practice something correct, something right? Again and again we have to repeat trying it. So it will become permanent. So practice, right?